A couple of things that we need to know about how our moods are, how our behaviors are, how do we develop certain toxicities and certain deficiencies and things like that. We have hormones that actually influence those bodily functions. So first of all, before we get into the hormone biosynthesis, we need to reintroduce ourselves to the roster woman and introduce ourselves to the roster man. As we can see, we know that there are hundreds of hormones inside of our body. But in this video tutorial, we will only go over 2 of them that makes us male and what makes us female. And those hormones are what we call estrogen, which is a feminizing, we're going to say feminizing hormone is estrogen, and we have the masculine hormone would be testosterone, so we'll say masculine down here. We recognize that these hormones are both needed in the male and the female, but it is more specific for the masculine to hold more testosterone and more specific for the female to hold more estrogen. Now, what are really hormones? And we know that they basically influence, or they are chemical messengers that influence our behaviors and our bodily functions, our behavior, our moods. So what are they really made out of? They are made out of cholesterol, guys. A lot of people already know these basic instructions, but from a chemist standpoint, we would say they are long chains of carbons that are attached by hydrogens, all by hydrogens, and they only come from animals. Now, we are animals, guys, so we make our own cholesterol. So we need to know that since we make our own cholesterol, plants do not make cholesterol at all. So we come down here and we form a estrogen, which looks similar to a testosterone. And because, you know, most roster men or most roster women would be vegan or vegetarian, we know that we don't get the animals cholesterol, so we have to be able to make those. So the liver has these biochemical processes that changes unsaturated fats into saturated fats and takes these long chains of carbon and hydrogenates them and loops them around into these rings, and that's what we call cholesterol here. And there's different types of steroid hormones and amino hormones and peptide hormones. There's hundreds of hormones inside of our body. But how this goes is that when we are developing in our mother's womb, we all start off as female. So testosterone, the masculizing hormone, has to differentiate those reproductive organs to turn them into male organs. And those organs are what we call testes. And around in this area here, I blew up here to show you that this is a testes from the left side view. As this young child is growing up, these male sex hormones begin to develop. And once he reaches puberty, around the age of 12 and 13, he develops these cells called Leydig cells. And they release this testosterone all over his body and into his bloodstream, where it is almost 7 times to 8 times more testosterone than a female his age. This is masculinity here. And inside of this testosterone, he not only needs just testosterone, he needs a little bit of estrogen, because there are other cells that are being stimulated at this time of puberty and so forth afterwards. It's never turned off. It's actually controlled by the anterior pituitary gland called luteinizing hormone. And it works on a feedback loop and continues on within the male's life as long as he lives. It is no switch off to turn off testosterone and him producing what we call here Sertoli cells. And Sertoli cells actually need a little bit of that estrogen, which is converted by just only 1% of that testosterone into estrogen to create the process of spermatogenesis. And that is what we call making up of sperm cells, the production of sperm cells. Now, we know most of us that have boys that are growing up, we've had children, and we see the boy growing up and he's getting a deeper voice, he's getting a little squeaky and he's going up and down, and you know that he's going through puberty because he develops what we see an Adam's apple. He develops an Adam's apple. And that is the deepening of his voice or the larynx. He also develops hair on his legs, pubic hairs, armpit hairs, even gets a little bit of that peach fuzz up under his nose. So testosterone is responsible for all of this, but also since it is working at a high level, he has so much quantity of testosterone inside of his body, he is able to perform 8 times stronger, 8 times faster. He has bigger muscles, bigger bones. He's actually taller than a woman. He's on average. That's usually because of testosterone. This is all these secondary characteristics that are happening within a male's body as he's reached puberty and on to adulthood. Now, as we've done with the testosterone with our first roster man, we'll go over here to the roster woman because we don't want to leave her out. She has a unique cycle of what estrogen does for her. Now, mainly it is estrogen that makes the feminizing hormone. In the female, estrogen is mainly produced inside of the ovaries. And the ovaries is where these little follicles are being developed by these cells called theca cells and granulosa cells. And that's where the follicle inside of this area, as I blew up and zoom in on this area here, follicles inside of the ovary is being matured. And those are stimulated by the anterior pituitary gland in the brain, the hypothalamus. The hypothalamus is like our thermostat, guys. We're going to get into that in just a few minutes. But it turns on the release of estrogen inside of the body. All of these granulosa cells and theca cells turns on the estrogen inside the body. So it hits a little bit here on top of the cortex of the adrenals, which is another endocrine gland. It produces some estrogen also there. It also produces a little bit, and it travels from the adrenals, to the ovaries, to the breast cells. Right here in the breast cells, it's also produced. And this is where, when our young girl, she's sprouting out and she develops breast. She develops what most women know as the Coke shape, that female fat distribution that is going on in the hips, the thighs, the hips, the thighs. She gets all of these different areas that are being developed and increasing because of estrogen. Now, also, this is during puberty and after puberty. She goes through a cycle, a female cycle called the menstrual cycle. And this is where estrogen is responsible for creating the endometrium lining. I'm gonna draw that in red because you already know why. The endometrium lining has to shed if she does not become pregnant. And the pregnancy hormone is basically progesterone. It means to prepare for gestation, which is pregnancy. So how does this all really work? Because I really want to talk about the menstrual cycle on a separate, different tutorial. Because it's a lot that's going on within these different multiple hormones. I mean, different hormones that are even peptide hormones that are being used in this area. So before then, I just wanted to talk about how does this really work? How does testosterone and estrogen find its way around the bloodstream after it's being produced either by these cells or either by these cells? It goes around, but first of all, when we're lacking something, it likes to be able to build it back up, or either if it stays lacking, we need to find a way to build it back up. So let's say, for instance, we look at this as a thermostat. The thermostat is set at 75 degrees. And the room temperature, it reads now, is at 70 degrees. It's a little chilly. So we need to try to warm it up about 5 degrees so that it can turn off. And then, the temperature is set right. That's exactly how estrogen works. That's exactly how testosterone works. And we work on this loop of feedback back to the pituitary gland and back to the ovaries or back to the testes. This is exactly how it works. So it sees these little receptors on top of our cells and floating through our bloodstream. It sees the receptors and it grabs onto that receptor. It's selective about which hormone is it looking for, which one do it need to express its function on, which one does it want to change its behavior on. So it enters the cell membrane and then gets closer to the nucleus. The nucleus is where our blueprint of how we are really made. So this is how certain cancers are produced, or just basically moves and behaviors, and it ultimately just changes that cell's function and makes it either get more muscles or build more tumors or build more cancerous cells or something of that matter. It tells the body exactly what's going on if something is infected, and it builds on that from there. Now, estrogen can be a bad thing. Estrogen could be a good thing. And just like cholesterol, you don't want too much of it because it can be a bad thing. Those who have cholesterol problems understand the hormones are off, and you got high cholesterol, high blood pressure at the same time. So when the woman comes around about 40 years old, when she gets around about 40 years old, the estrogen levels start to decrease. And if there's not enough estrogen in the body, the bones actually start to decrease its volume. So estrogen is needed also within our bone structure. So it relies on testosterone to prevent her from getting osteoporosis. So she can have these androgens that are floating around her body that can either become too much or become too less. And this is where, certain hormones get converted over to other hormones like DHT. So if it gets into that section, then it can go in the wrong direction. But this is how the hormone biosynthesis works. Everything is made out of cholesterol, and we produce the ability to make cholesterol if you are vegan, and if you are not, you're getting it from the animal source. So thank you guys for listening. I hope this is clear up a lot of different understanding, so that you now understand now.